In this video, we'll cover some of the questions that came in CAT 2008. I have chosen 5 questions across topics just to give you a flavor of what was the difficulty level of the questions asked in that examination. So this is the first question. And in this question, what is provided is that the length of side AB and AC of a triangle are 17.5 and 9 centimeters. So I've already drawn the diagram. The diagram was not part of the question, so you had to draw the diagram post reading it, but it's not very difficult to draw. So 17.5 and 9 centimeter. D is a point on the line segment BC such that AD is perpendicular to BC. So this line is perpendicular, and this length is given as 3 centimeter. Then we need to find the radius of the circle circumscribing the triangle. So we need to find the circumradius for this triangle. Now, the way to do this, and it's easy to get confused in the examination, but you need to remember this formula for solving this question. So this is S is equal to ABC by 4R. So this is the formula for area of a triangle, which is A into B into C by 4 into the circumradius. So as you can see, there are a few lengths here which we have been provided, and it has R, which is the quantity that we need to find. So you can probably do this much of thinking and realize that this is the formula that will need to be used. Now, how do we use it? So from here you can imply R is equal to ABC by 4S. And now, let's see, we have two sides, we don't have the third side. And people who tried calculating the third side would never reach the answer because the calculation becomes too tricky, it would become too long, and you won't be able to solve it if you try and go for that. So what would be easier to do is you start substituting the values, 17.5 into 9 into BC, whose value we don't know, and then 4 into area of the triangle. Now, what is the area of the triangle? Half into base into height. We have been provided one height, which is AD. So if we put BC as the base and AD as the height, which is 3, and now we can cancel BC in the numerator and the denominator. So this was the trick which was needed to solve this question. Post that, it becomes extremely simple. This is 17.5 into 9 by 6, which is 17.5 into 1.5, and that would be equal to 26.25. Let's look at another question. This was another question on geometry in CAT 2008. So here, this is again regarding length of a triangle, and what we have been given is for an obtuse angle triangle, there are the two lengths are 8 and 15, and the third one is x. If x is an integer, then how many such triangles exist? So first you will have to make two cases in this kind of a question, because we do not know whether x is the largest length or 15 is the largest length. So if x is the largest length, then this angle will be obtuse. This is 8, this is 15, and this is x. And the other case can be where 15 is the largest length. So we have 8x and 15. And you'll have to analyze both cases. So let's look at this case. In this case, first thing we know is that sum of two sides of a triangle has to be greater than the third side. So x will have to be less than 15 plus 8, or x will be less than 23. What we also know is that 8, 15, and 17 are a Pythagorean triplet, which means that for 90 degrees, this will be the scenario, 8, 15, and 17. So as we increase this angle, x will have to be more than 17. So x will be greater than 17 and less than 23. So combining these two, we can say that x will be 18, 19, 20, 21, and 22. These are the 5 integer values that x is allowed. We'll have to analyze the other scenario as well. What we'll use is that the difference of two sides has to be less than the third side. So x will have to be greater than 15 minus 8, or x will have to be greater than 7. Plus, if it were a right angle triangle, 8x and 15, x will have been equal to under root 15 square minus 8 square, or equal to 225 minus 64, which is 161. And this would be roughly 12.8. We need not know the exact value, we just need to know that it's between 12 and 13. So as 15, this angle becomes bigger, x will start becoming smaller. So x has to be less than 7, greater than 7, and less than 12.8. And from here we'll get the values 8, 9, 10, 11, 12. Based on this, you can say that there will be 10 solutions and so 10 will be the answer. So to do this question, you need to know properties of triangle and you should have them at your fingertips. Once you have that, it should not be very difficult to come to these. So this is the third geometry question in the same paper, and this is based on circles. So what we have been given is that there are two circles of radii 1 centimeter which intersect each other and pass through the center of the other. What is the area of the intersecting region? So this diagram here was not provided in the question. I have drawn it, but let's see how we would approach this. So the radius is 1 centimeter, and we are supposed to calculate the area in between. Now, how can we do it? What we do know is that this length is 1. So is this length. Sorry for my drawing. This is 1. This length is 1. This figure is symmetric around this line. Right. Around the middle part, it's completely symmetric. So that helps us a lot. Even without proving stuff, we can make some assumptions. But if we join these two, these two will be equal. And we can say this because it's symmetrical. So there is no reason for it to be longer on one side. If these two are equal, same way we can say that this angle will be 90. Again, because of symmetry, there is no reason why this angle should be anything different from 90. And since this is the radius of the circle, which is given at 1, this will be 1 by 2. And since it's a 90-degree angle, you can calculate using Pythagoras theorem that this is root 3 by 2. Once you have calculated this much, you can very easily calculate the area. The way to do this would be, you need the area of the entire overlapping region. Just calculate the area of this part and then multiply it by 2. The half of the region that you would need to calculate. And the way you will calculate that is, you'll just look at one circle and calculate the area of that segment. Let's see. So let's just look at the first circle here. And what we have been given is, we have found out that this is 1, this length is root 3, and the perpendicular here is 1 by 2. That's what we have. We need to find this area and then multiply it by 2. And the way we can do it is, if the total angle were theta, then the area of the sector will be pi r square theta by 360. And then we separate the area of the triangle, which is half into base, which is root 3, into height, which is 1 by 2. Now, how do we find theta? Theta is easy to find because this will be theta by 2, as these two triangles will be congruent, similar, based on symmetry also you can say. And using a bit of trigonometry, you can see that cos theta by 2 is base by hypotenuse, which is 1 by 2, which implies theta by 2 equal to 60, or theta equal to 120 degree. So that angle is 120 degree. So you can make this pi r square into 120 by 360, or 1 by 3, minus root 3 by 4. Radius is 1, so this is pi by 3 minus root 3 by 4. And this is area of one segment. So the total area will be 2 into pi by 3 minus root 3 by 4, or 2 pi by 3 minus root 3 by 2. This would have been the answer. It's a lot easier once you do it yourself. It might seem more difficult when I am doing it. So just try it out yourself. We have done 3 questions from that paper. The paper was not an easy one, but it wasn't a very difficult one either. We'll quickly look at 2 more in a separate video.